going to do this presentation in two parts. I'm going to cover the transistor part. So basically, this is what a transistor looks like in one form. There's three main parts: the emitter, the base, and the collector. And there's also two kind of flavors. It could be an NPN or PNP, and you can tell by this little arrow here. And there's two main functions of a transistor. One is to be a switch, or one is to act as an amplifier. The switch is controlled by the voltage on the emitter and the base over here. So if it's forward biased, meaning it has 0.7 volts, it'll close the contacts between the C and the E, and in this case, it'll connect your motor to ground, and it'll start working. In this case, it is not forward biased, so there's no voltage across B and E, and you can see between C and E, it acts like an open switch, so the motor's not running. The other configuration is the transistor as an amplifier. Basically, the big difference here is with the voltage divider. With this, it controls the gain of the transistor, so it doesn't matter what the gain of the transistor is, it'll always be the same, as different transistors can have different gains. And now, how to put the other half.
Power supply. So we decided to start off with a half-wave rectifier, which has the diode and one resistor. So that gives you a waveform like this, where it just has the positive, and then it goes flat. And because there's no negative when the AC goes in the opposite way, it's blocked by the diode. So here's kind of the offshoot for the diode. There's 0.7 volts. If it's in the reverse bias, the current is going to be blocked. That's why you get there's no negative. And then if the current flows forward, that's where you get the positive portion of the wave. So and after, if you're going to build a full wave rectifier, which you're going to end up being able to get the full wave, you start off with the half wave rectifier, add on a bridge rectifier with 4 diodes. So just from that, you're going to be able to get your full wave. From there, you can continue on to build a DC power source. So from there, you add on a capacitor with the resistor. So they're both going to be hooked onto the bridge. The capacitor ends up giving you the ripple. By here, we put this probably in the wrong spot. Should have been over there. But, so that's going to end up with the ripple. So it's going to give you a higher average voltage. After the current regulator, we're going to be adding on with the Zener voltage, which is going to stabilize the wave, so it just keeps it straight, one solid voltage level. That's it.
We have the power supply. We need to know, first of all, how the diodes work. When a diode, well, the current goes this way, well, the diode is considered forward biased. If the current would go on the other way around, then it would be considered reverse biased. Now, playing with those features of the diodes, we can build a half-wave rectifier, which would basically allow the wave or allow the current to go in one direction but not come back, so it would basically cut the wave in half. Now, if we continue playing with the features of the diodes, we can build a bridge rectifier, which would allow us to rectify both parts of the wave without cutting it. Now, once we have this, okay, if we add a capacitor to the setting, we will higher the minimum, the values or the minimum voltage here, creating a ripple effect and a higher average voltage. So now, if we add to all that, setting the Zener diode, we would achieve a more a steady current, a steady direct current, And, well, this is a little bit upside down. Well, the RS, the resistor, we have here, if we add it, we can also control the amount of current that goes into the Zener diode. First of all, to allow it to have the minimum current, so the minimum current necessary to work, and also to prevent for the whole system to blow on this side of the Zener diode. Now, the transistors, well, the transistors are devices that work as switches or as amplifiers. They consist of an emitter, a base, and a collector. Now, we have two kinds, well, the NPN and the PNP. In this case, the NPN, we see that the base and the emitter are forward biased, and the PNP, well, the base to emitter are reverse biased. Now, in this case, for example, if we have also the collector and base forward biased, we would get a saturation mode, which would allow us to use the transistor as a switch. And in the PNP, but if we have the base and collector reverse biased, it would be working rather as, in the active region, as an amplifier. Now, a PNP transistor, it basically would act, if reverse biased, like here, well, it would cut the current from flowing in that sense, like from C to E. Of the configurations in the active region, we have it as voltage divider, which would be the perfect amplifier, or the close to perfect amplifier. The emitter stabilizer, where there's a resistor that modulates the output into the emitter, also into ground. And fixed bias, where base and collector flow into emitter.